Hello world! Today I'm going to install a hydraulic clutch on my Yamaha XS650 motorcycle. This is the left side case cover. This here is the stock clutch actuator. There is a cable which attaches to this gear right here. When the cable is pulled, this gear pushes towards the engine. It pushes on a push rod which engages the clutch, separating the clutch plates. This is the cover that I'm going to do the hydraulic clutch modification to. In an earlier video, I repaired this cover. It had a broken bolt hole here. I will link to that repair video down below. I have already removed the stock clutch actuator, and I'm going to, in its place, be bolting this. This is an Aprilia slave cylinder for an Aprilia motorcycle hydraulic clutch mechanism. The finished system will look something like this. Hydraulic master cylinder attached to the handlebar, a hydraulic line attached to the Aprilia slave cylinder with a banjo bolt that incorporates a bleeder. Perhaps the hardest part of this modification will be bolting the slave cylinder to my cover. I have already laid out my bolt hole location. I took a bit of time doing this. I tried to lay it out as accurately as possible. I found the center of an appropriate plug. Then, using a compass, I drew a circle, a pencil circle, which I think you can just barely see. The piece of tape was to keep the compass point from wandering while I made that circle. Then I made a template of the hole location, which I was then able to lay on the cover and trace my hole location. So you don't really need to go to all that trouble, but it never hurts to be accurate. So now let's drill our holes. The flat plane of the gasket surface on the cover is interrupted by this protruding pin. So I have taken a board and drilled a hole in it, which that pin fits into, and now my cover sits perfectly flat. And I can drill the slave cylinder mounting holes in my drill press. To begin, I'm using a center punch to mark the center of my holes. I now have 3 1/8 inch pilot holes. Next, I will counterbore my holes using a 5/8 inch square counterbore tool. Here I have begun my counterbore, but I purposefully stopped just a little bit shallow of my final depth. And the reason for that is I want to come over here to where my depth gauge is on the drill press, and I'm going to set the depth gauge right here. I've actually already done it. I'm going to set it just a little bit deeper than where I'm at now. So now I can use my depth gauge to get the final depth of my counter bore, and then when I do my other two holes, they will all come out to exactly the same depth and be exactly level with one another. I'll also mention that this is the lowest of the 3 holes. So I want to remove the minimum amount of material necessary, and that's why I'm using the low hole as the gauge for the other 2 holes. So let's take a look and see how good a job I did setting my depth gauge. That'll work. I've made 2 of my counter bores, and now I'm going to make the final one. My 3 counterboard shoulders are now completely level with respect to one another. I can put a washer on each shoulder and then double up my washers, and I now have a perfectly level surface to place my slave cylinder on. And my slave cylinder is now completely square with the rest of the engine. I did have to come back and remove a little bit of material right here and right here, or I could have gone to triple washers on each counterboard shoulder, but triple washers just would have meant more parts, and it would have meant holding the slave cylinder further away from the engine, sticking further out. Neither one of those was a really great solution, so instead I just had to remove a little bit of material here, and I'm now ready, just about, to bolt this onto my side cover. This is an early XS650 one-piece clutch pushrod. It was later replaced with a 2-piece clutch pushrod and a ball bearing. The Aprilia slave cylinder sits out further from the engine than the stock clutch actuator, and for that reason these rods will not be long enough. So what I will be doing is taking a short rod and combining it with a long rod, a long one-piece rod, and then I will trim the long rod to the final length that I need. I've got my cover mounted, and I'm going to determine final pushrod length. Both pushrods are in the engine. I've mounted a piece of stiff white plastic card using screws in the original clutch gear mounting holes. Now I can make a mark on the rod where it contacts the white card. This will be my first rod length measurement. I've removed the cover again and mounted the slave cylinder to it using temporary nuts and bolts. I've inserted a rod for measurement purposes, and I will mark the rod where it contacts my straight edge. This is the same contact point that my white card earlier registered. The distance from the mark to the end of the slave cylinder socket is my second rod length measurement. The Aprilia slave cylinder contains a preload spring. The measurement from fully loaded to fully unloaded is my third rod length measurement. The final push rod length will be the total of all 3 measurements. Finally, I have installed M6x1 stainless steel threaded repair inserts into my original 3 holes. These are commonly called helicoils, but the brand I like is Recoil by Alcoa. This is a very nice kit. The depth of the cover after making the counterbores is a bit thin, and the threaded inserts are very strong and a huge improvement over directly tapping the aluminum cover. You could use nuts and bolts, like I temporarily did when I was measuring for pushrod length, but by screwing into the cover, you can remove the slave cylinder without removing the whole cover, which I promise you will find very convenient. So there's the basics, and for many of you, that will be enough. If you want to stay tuned, the remainder of the video has some good additional info. Everything is now installed. I have the Aprilia slave cylinder bolted to the side cover. It is connected to a brake line which comes up to the handlebar. I am a big fan of cheap Chinese master cylinders, which is what this is. This is a $20.44 eBay master cylinder. My research was telling me that I should be looking at around a 13 millimeter bore master cylinder. This one is 12.8, so we will see how it works. I normally make my own brake lines, but I was out of fittings and I did not have time for them to arrive. So what I've done here, I have this brake line coming around. This is obviously a pre-made brake line which I bought a long time ago, and this brake line ends right here where I have it connected to one of these. This is a Yamaha XS650. It's called a joint. It's the original front brake line is a two-piece brake line on an XS650. So one brake line would attach here, the other brake line would attach here. So showing you from the other side that this first brake line connects to this joint, and then I have a second brake line coming off the joint right here, coming around here, going through the tachometer cable guide, and then coming around the other side to the slave cylinder. So again, here's that joint where the two cables meet, and I've got it sitting where the stock coils would normally go. Normally you would have two single coils here. I'm running a PAMCO ignition, so instead I've got a single dual tower coil mounted up here. It left this space where I was able to mount the joint. So I have added fluid to the system. I have bled the brake lines, the hydraulic lines. I'm going to quickly interrupt myself here and mention that instead of .3 brake fluid, I used mineral oil intended for bicycle hydraulic brakes. The clutch slave is not a high heat application. You don't need .3, and I highly recommend that you don't use it for the reasons on the screen. Now back to our video. So I have added fluid to the system. I have bled the brake lines, the hydraulic lines. I'm sure there's YouTube videos showing how to do that, so I'm not going to get into it. And I have not run it yet, but I've rolled the bike around, shifting gears in my workshop here. One more thing I need to mention is that the slave cylinder sticks out pretty far, and there was a clearance issue with the shifter pedal. So I found this is a non-XS650 shifter pedal. I don't really know what it came from, but I was able to bend it around the slave cylinder, so now I have the required clearance. So I have not run the engine yet, but I've been rolling the bike around in the shop shifting gears. And what I discovered is that right now my clutch push rod is too long. So it shifts easily, but I have got like almost total slippage because the plates never come back together. They stay separated. So what I did was I loosened my cover bolts, which allowed me to pull the cover away from the engine just like 3 or 4 millimeters. And that little bit of gap there, that 3 or 4 millimeter gap, has the effect of making the push rod shorter by 3 or 4 millimeters. And now it seems to, now it engages just perfectly. At least rolling around the shop it does. You could also test push rod length by adding washers right here. That would have the effect of pulling the slave cylinder further out and thus effectively shortening the push rod. So yeah, you could add additional washers back here until you get it just right, and then you could shorten the push rod by the amount of those washers that you added. The clutch has been working like a dream. Time now for a 500-mile inspection. This is a 500-mile update. I want to inspect the push rods for wear. So we'll pull out the long rod. I purposefully left out the 8mm ball at this time just to see what would happen if I didn't use it, but I will be putting it back in after this inspection. I've got a long rod here with a 5mm neodymium magnet glued to the end, which I bought on eBay. I'm going to use it to remove the short rod. And now, if I can, I'm going to try to pull out the far ball bearing. Here are the push rods, which I just pulled with my little magnet tool. I did eventually get the far ball out. Took a little doing, but I got it. To reiterate, this is a stock short push rod. This is a long push rod that I have shortened. You can see how much it was shortened, not very much. Some people go out and make their own rod, get a single piece rod. If you do it my way, I would strongly suggest that you put the narrow end of the rod on this side, the outwards facing side, like I've got it. This is the narrow end here, to facilitate pulling it with a magnet if you ever want to do that. So as it stands, my length is perfect. The clutch has been working perfectly. I get into neutral under any condition, stopped moving, hot, cold, with 0 problems. So it works really great. But I don't exactly know why I'm compelled to do this, but I want to put the little ball bearing that's supposed to go here back in. This was kind of an experiment to see what would happen without it. It works just fine, but I do want to put it back in there. I'll also mention, as I said before, this is the 500-mile inspection, and I very carefully looked at all my parts, all my ends. I was looking for metal particles or any kind of unusual wear patterns or anything suspicious or wrong looking. And everything looked very, very good. So now what I'm going to do, like I say, I'm going to shorten the long rod here one more time. This is an 8mm ball, so I'm going to shorten the long rod by 8mm. And then one more thing I'm going to do, and just to make sure everyone's clear, the clutch is over here on this side, and the slave cylinder is over here on this side. What I'm going to do is I'm going to put, I got these on eBay. They actually had to be imported from the UK. These are 0.2mm thick washers, and they are also 8mm outside diameter. So 5 of these will equal 1 millimeter. So I'm going to not only cut off 8 millimeters to allow for the ball, but I'm going to cut off an additional 1 millimeter, and I'm going to put 5 of these 0.2 millimeter washers in the bottom of the socket of the Aprilia slave cylinder. That way, if it turns out that I think the clutch rod is too long, I can just remove one of these 0.2 millimeter washers. And believe me, 0.2 millimeters is going to have an effect that you will feel when you're using the clutch and riding the bike. And conversely, if somehow the rod is too short, I can just add another one of these 0.2 millimeter washers, and I should be all set. So I have an easy way to adjust if like the friction plates wear out, or if something happens, who knows what. I have a very easy way to make very small incremental changes which will have an effect on the operation of the clutch lever. I also did a 500-mile inspection of the piston bore. Before I put the push rod in, I had lubricated the socket, and I did the inspection by running a Q-tip in it, and I got a little bit of color, but I really think that's just a little bit of the anodization on the socket, so no problems there. I also did a visual inspection of the inside of the socket, and everything looked good. Here we have the finished Aprilia hydraulic clutch modification on my award-winning 1973 Yamaha XS650, also known as an XS650. This bike is a multiple award winner in the rat bike category on the local circuit, where it is popularly known as the Super Rust Bucket. It features a working skateboard seat with a Mexican blanket cushion. The front wheels of the skateboard sit in the original tool tray, and the rear of the skateboard is held on with a single U-bolt on the seat loop and 2 wing nuts, so 30 seconds later and you're skateboarding. The Super Rust Bucket also features an exhaust dump header pipe, a tribute to old school hot rods. You remove the dump cover for increased airflow on the drag strip. I'll say again that the clutch works fantastically and easily goes into neutral under any condition, hot, cold, moving or stationary, with no problem, and has a pretty darn easy pull. Here's a quick cost breakdown. The whole thing cost $161, and that includes almost $20 for the counterbore tool. Finally, let's admire the Super Rust Bucket's very cool 45-year-old vintage pinstriping on all of the tins, on the tank, on the headlight bucket, on the side of the tank, and on the side covers. They don't do it like this anymore. Thanks for looking, and be careful out there.